Can you help me a bit? Who here has seen people on bikes or scooters around the city carrying a colored bag? If you can raise your hands. And who here ever placed an order on Glovo, Foodpanda, Bolt Food, Uber Eats, Taz? But did you know that this scooter existed even 2,000 years ago? Of course, in a different form with a bit of more personality. Back to the ancient city of Rome, Caesar was known for his extravagant banquets. He hosts tonight a new party with hundreds of people invited. He takes a piece of yellow pergament from his pocket and says, "For tonight's feast, I would like the roasted wild boar. And bring me some exotic flamingo tongues along with that on the side." Now you might wonder, how can Caesar procure such exotic ingredients without the convenience of modern transportation? And in fact, Caesar was relying on a network of couriers and messengers that knew how to navigate the busy streets of Rome. And they even had a special name for that back in Rome. I cannot pronounce it, but you can look it up. So once the servants heard the order, they would jump on their horses, they would go through the small streets of Rome, find the right ingredients or fresh, already cooked meals, and bring them back so that Caesar can have his feast. So as you can see, even back in ancient times, Caesar relied on a very sophisticated system of a network of couriers and messengers to bring the world's flavors to his doorstep. Then, we had the medieval inns and taverns, where people can go inside, they can order food, they can also take away, also get some food delivered. Fast forward to the telephone era, when your favorite restaurant started to be just one phone call away from you. And then we had the pizza times, if you remember the 90s, the 2000s, when people used to order pizza, had small parties at home, gather with some friends, have these small get-togethers where you were eating pizza. And that brings us today, where we have apps like Uber Eats, Bolt Food, Glovo, where people can just open the app, find their favorite restaurant, make the order, and get their food delivered within minutes. So, as you can see, food delivery has been on humanity's minds since the beginning of times. It's not a new concept. And if you think about Caesar, the system was quite the same. There's nothing really changed, right? Technology on top of that. But everything is the same. The future looks a little bit more robotic with drones and robots bringing groceries. Actually, in my last visit to Los Angeles, I've seen one of these small robots on the street carrying a bag of groceries. So companies are already testing it out. Had a bit of a long introduction, but good day, everybody. Thanks for being here. It's so good to be back here on stage with you. It's been a year already. My name is Dan. These are some of the products that I helped build over time. You might recognize or even use some of them. But what they all have in common is that they serve millions of customers every day. So that has been my passion so far, solving large-scale distributed problems and big data challenges. When I'm not engineering, I do a whole bunch of other stuff, have tens of other passions, but I can talk about hours and hours about that, maybe after hours or in the coffee break. But back to millions of customers. Bolt today is one of the fastest tech companies in the world. We serve today more than 150 million customers. So if you think about it, that's not far away from half of the population of the European Union. We operate in 45 countries, 500 cities, and we employ more than 3,000 people. So food is a $1 trillion industry, the same like housing and traveling. So launching Bolt Food was the next logical step for Bolt because we learned so much from the ride-hailing business. We wanted to apply the same concepts, bring the same goodies to the food industry. Offer our customers a more affordable way to order food while giving really, really good conditions to the couriers. We're helping restaurants to increase their customer base without them having to worry about advertisement, reaching out to new customers, hiring couriers. So today we have 35,000 restaurants on the platform. If you think about it, if you want to try a new flavor every day, it's going to take you 96 years to finish all these restaurants. Of course, it's going to involve a little bit of traveling, but hey, is there ever a bad reason to travel more? not in my books. Last month marked the 4-year anniversary of Bold Food. We launched in September 2019, and since we've been talking a lot about history today, I wanted to walk you through some of the main problems and challenges that we had to solve these 4 years. If you never thought about the ecosystem and how things work together, we have 3 main applications. We've got the Eater app, we've got the Courier app, and the Merchant app. The Eater app is the app that we mostly use. You open it up, you find your favorite restaurant, you place the order, you get your food delivered. Then we have the Courier application. This is the application that couriers use in order to receive orders, navigate, and also see how much they earn. And then we have the Merchant app. The Merchant app allows restaurants mostly, but we have grocery stores, flower shops on the platform as well. So by merchants or providers, I'm referring to all of these people. It allows them to accept orders, change menu availabilities, and so on. We've got a bunch of other apps, like the merchant portal, but this is to get more detailed reports about the business, and so on. We won't talk about it today. This is not part of the show. I only brought some water with me. Safety first. You know, I had no hands to carry it on the scooter. So one of the main challenges on our mind is how to get the food delivered while it's still warm. And so we started to think about the delivery matching system, how we match couriers to orders, what's the right moment in time so that the food gets warm to you, and also the courier make the most money. We started off with a really simple approach. We called it the instant dispatch algorithm. It's a greedy algorithm. We used KD trees to calculate the distances between couriers and restaurants. But how it works is that whenever somebody places an order, we immediately assign a courier to that order, and it starts traveling to the restaurant. So you might already notice one problem. The courier may be 5 minutes away from the restaurant, but the food may be cooked in 45 minutes. So this raised the question from the couriers, are you ready? Are you ready? Are you ready? Is the food ready? Is the food ready? They were in front of the restaurant, gathered around, and asking the restaurant if the food is finished. Then, we thought, how can we solve that problem? Late dispatch, you might already guess how it works. But we started to look when the courier we started to estimate when the courier will get to the provider. So with this, we assigned the best available courier that will arrive at the restaurant when the order is ready. With this, we reduce the courier waiting time. And this might give you a better understanding how this all works. I know where to show. So if your order is created at 8:30, then we don't assign a courier immediately. We just wait until we kind of know that the cooking time and the estimated arrival time of the courier is sort of the same. Every 20 seconds, we run an iteration and see if this difference is small enough to make the assignment. The cons are that we rely on the provider and the courier to be ready on time. So that introduces delays to the customer. And sometimes the courier is just next to the provider in front of the restaurant and they don't get the order. They see that the restaurant accepted an order, but they don't get the order and they are sent 5 minutes away. So the question comes, why am I not assigned to this order? I'm in front of the restaurant and the restaurant just accepted the order. What's going on? Next, we thought, hey, why don't we put more orders in one go? Like one courier can deliver more orders. So I'm talking about batching now. I'm going to go back at the previous one then. With batching, we wanted to assign more orders to the same courier. So instead of delivering just one, they would get 2 or 3 orders from the same provider and get them going. We started to match the couriers based on proximity. So if you have close restaurants or close eaters, or the time of the cooking is somewhat similar, then we would group more orders together. With this, couriers obviously earn more because in less time they can deliver more orders and get more money. We deliver more orders with less couriers. And obviously, it comes with some bad stuff, because once you have more actors involved, then more things can go wrong with so many parties involved. Let me tell you a bit about the one that I jumped over, the back-to-back dispatch. With this algorithm, still a greedy one, we don't look at the available courier anymore. We look at the entire set of couriers that have the app opened. So they work even though they have some orders in progress. But it might happen that one of the couriers finishes the order just near the restaurant where they can pick up the next. So then we wait, and we try to assign the best courier that will arrive at the provider when the order is ready. Again, reduces the delays and distance to providers. The supply doubled because we look at all the couriers, so it's not only available ones. Shorter distances traveled, and less waiting time. Cons, of course, we rely on the previous courier to finish the order in time. There's also another uncertainty. What if the courier doesn't accept the order? With this, if you know the driver application, Bolt or Uber, you've seen it, when you call a cab, sometimes you get this message on the screen that the driver is finishing a trip nearby. Right? It works in a very, very similar way, just that we don't inform the customer, because with our prediction algorithms, things may change on the spot. So every iteration, we do a first-come, first-served kind of model. The courier is assigned. If it's not assigned, then it's taken into account in the next iteration. This is an example of batching, just coming back to the batching. The first one is how we matched by proximity. So say a courier picks up an order from this restaurant over here, then there are two eaters which are just nearby. So it just picks up two orders and then travels all the way through Bucharest, leaves them there. In the second image, you can see that proximity is not the only thing that we can batch upon. So we started to improve this algorithm. Here, you would pick up the order from the initial position, but on the way to this user, there is another restaurant which needs to deliver here. So we would pick up the second order from here and deliver to both of those eaters. Batching during COVID. COVID is always an interesting topic. If you remember in COVID, when you tried to order over lunch, you would mostly get the message that the demand is too high and a lot of the restaurants are unavailable. Because indeed, the demand was too high and we didn't have enough couriers to match all the orders. So we were like, why don't we just send 20 orders at once instead of 2, 3? And we had to do this in 1 week. So at 1 p.m., whenever one restaurant has 20 orders ready, then we would pick a courier. It will go and pick up all the orders from there, and we use a nearest neighbor algorithm. If you remember those things from high school and university that we thought we would never use, I thought I will never use. It's happening here, and it's going to deliver one by one shortest distances at every step to get to all the users. Now we started to get serious, because we started to move away from the greedy algorithms, and we started to look at the entire city holistically. We need to decide who picks up an order, so then we compute a cost for each courier in the city and try to match it with every order in the city. So if you check over here, you have a bunch of costs computed, right? It's a sort of every courier has a cost associated with every order. And we need to choose the combination of matches that is most optimal at city level. We use the Hungarian algorithm to compute the metrics. And for example, one thing that goes into the calculation of costs is the total ETA, just one parameter that goes in. That is in minutes and not travel distance, because there can be multiple vehicle types of the couriers. So with this, we solve the entire set of jobs and supplies in one single optimization problem. This is already solved. You won't get much from this one, but I think I have a better slide here. This one shows really the difference between the greedy versus the matrix dispatch algorithm. So with the greedy, if you remember, we assigned the nearest courier available, say, takes 1 minute for that car to travel to the restaurant, and then we make the second assignment, which is a 7-minute travel to the second restaurant. So that was with the initial versions. With the matrix dispatch, we look at the entire city, so we see that the costs are a little bit different. We send the first car to the second restaurant. It takes 3 minutes in travel time, and the second car to the first restaurant, so it takes 2 minutes. The first courier obviously travels a little bit more, but if you look at the entire thing, it takes 5 minutes in total, rather than 8 minutes what we had before. So we're saving time at the cost at the city level. Policies. We started to add policies. In some countries, you are not allowed to deliver alcohol if you don't have a license. So we've added different kinds of policies. Cars only, no parking. No parking if you go to Centru Vechi, right, in the old town square. There's no way to park. So then we get rejections from the couriers. They don't want to pick the order because there's no way to leave the car. It takes a lot of travel to go inside the Centru Vechi and get the food. And so we added all these policies. Obviously, it impacts a bit our courier pool because once we have the entire courier pool, we need to filter them out so we don't have that many couriers anymore. Somebody used the same Giphy earlier in the presentation. I'm just a copycat now. But we started the machine learning journey as well. So the first thing that we do is that we started to ignore the cooking time which was given to us from the restaurant and try to predict the cooking time. Because we get a constant, for example. We say an average cooking time for this restaurant is 40 minutes. And instead, we started to use the probabilistic preparation time model. It reduces delays, it reduces courier and provider waiting times. We also use ML predicted ETAs. We use our own mapping system. We don't use Google Maps, for example. Google Maps is great for us as end users, right? You can use it for transportation, to travel by car. You can also do some bikes in some cities, but for us, we have much more tailored use cases. So using our own mapping system allows us to know what's the traffic for different vehicle types in Bucharest, for example. Google Maps doesn't have that. We also know that if you go to a mall to pick up an order from a mall, it takes time to park, to go 2 stories up, get the food, go back to the parking. So this is always added time to the order, which Google Maps is not aware of. There's a bunch of other crazy stuff that's happening. For example, we can predict if a courier opens the app near a restaurant. So we don't immediately assign couriers if, with some probability, we know that somebody will open up the app and start working near that restaurant where we have the order. There's much more to machine learning, but it's way, way over my pay grade. But there are some nice presentations on YouTube that you can watch, and it's better explain how we use all these algorithms and predictions. Oh, enough about that. Let me tell you a bit about menus. You may think menus are easy, and we thought as well. There's a restaurant. If you go inside, there's a paper menu, front and back, with a few options available you can choose from. Unless it's one of those Romanian traditional restaurants where there's a thick menu. You know what I'm talking about. They've got soups, pizza, pasta, burgers, sarmale, desserts, everything from. But even then, you've got 50 options, right? Maybe 100. We started off with representing the menu as a tree structure. So you've got the menu on the top. Then you go down, and you've got different categories, say pizza, pasta, recommended daily dishes. One dish can be part of multiple categories. Say vegetarian pizza can be part of pizzas and also part of recommended dishes for the day. Then you have multiple option groups, added ingredients, added juices. For example, you can add pineapple on your pizza. I don't want to start a war in here, but who likes pineapple on the pizza? Okay, there you go. Some people here. Now you know whom to talk to in the after hours, right? You know whom to be friends with. No, I'm kidding. Everybody's friends here. So then you add or remove your pineapple from your pizza, and those are the options. You can add stuff, you can add mozzarella, you can add salami and whatnot. We put the menu into our MySQL relational database, and that's how it started to work. We started off with something really, really simple, where providers/restaurants, they don't have the possibility of changing it. So you can imagine, once we got more restaurants on board, they wanted to change their item availability, their prices, their descriptions. So we started to get 600, 700 requests like this every day. And there's a lot of manual work involved. So obviously the next step for us was to add a menu editor for all these restaurants to be able to change it. Things were working fine, just that with every change, we duplicate all the menu items. So you change one small description, you made a typo in your pineapple, you have to copy everything what's in the menu and duplicate all the data. And you might say that's not a problem, and it's not. Storing data is cheap, a menu is not that big, but things go wrong and hell unleashed when we launched Bold Market, because with supermarkets you have tens of thousands of products in the inventory. So every addition, every removal of one item, every small typo change means duplicating the entire menu. It takes sometimes even 5 minutes to insert all this data in the database with every small change. So we easily ended up with having database deadlocks. We slowly, well, not slowly, but actually exponentially started to exhaust the MySQL space for integers for primary keys. So we couldn't be able to store menus anymore. And today we're working on a new version. We try to represent the menus as a graph rather than as a tree structure, try to make connections and refer rather than duplicate, refer items from the previous menus, version to version, and so on. The duplication of menu actually comes with some nice features. You can unlock stuff like recommended dishes in the application, because we know what people had before exactly, so we can give them some recommendation, or the feature which is order again. It works on a similar basis. This is how the flow looks today. You basically create a menu through different means, either integrating via API. If you think about the big chains like KFC, McDonald's, Subway, they don't want to send us or insert menus manually. So they integrate through an API and make all the changes through the API. Then you have the menu editor, where restaurants can change their menus. And we also insert menus on our own using an Airtable import. You get into a draft state of the menu, and then it needs to get approved. Once we check all the images are fine, the descriptions are fine, the menu gets approved, it can be linked or unlinked to one restaurant and make it active. Well, we're getting close to an end here, so I wanted to share some stories from the field with you. If you remember, back in the summer, we had this huge storm. Everything was nice during the day, one of those 40 degrees days. People were eating ice cream on Cala Victoriei or just inside their house. But in the night, at 7 or 8 p.m., this huge, huge storm started. So you may already guess what happened. People were ordering their dinners. The storm started, all the couriers went inside to safety. We were getting the red alert on our phone. Go inside, trees are falling out. And so nobody was there to pick up the orders. So turns out that, we can predict many things, but not the weather. And this is how the chart on that day looked like. This is delayed orders in minutes. So you can see, now we know the date, it was the 5th of July. You can see that there's a nice curve with a few minutes of delays usually, and then you get this spike, 2 hours delays. Restaurants started to close down, people were not getting the orders. So when the storm stopped, the couriers went back, picked up the orders, tried to deliver the food where it was still possible. People were hungry. I remember we had a lot of customer support requests. we realized that some restaurants are not where they say they are. So if you put a pin on the map, sometimes it's not the right one. So we had locations of the restaurants in one place, but in fact the restaurant was just 30 meters away from the actual location on the map. So couriers were getting there, they were trying to find the restaurant, and there's no way to find it. So they were just like going around different streets, consuming fuel, energy, if you're biking. So we were like, why don't we know where the couriers stop because we can see that in their applications. Why don't we sort of predict the actual location of the restaurant? This is a real example from Bucharest. The restaurant was there on the map, but the actual predicted location was there. So we started to just move the restaurants away in Bucharest, and we saved on average 10 to 15 seconds per order and 150 kilometers per week in travel time. Once we expand this globally, it's going to result in 7-digit figures in courier saving costs. So that's enough to take 1,000 people to a huge, huge party for 1 week in Monaco. This is a really good example of economy at scale, right? Because we make small changes. If we save 1 cent per order or in time for one order, then if you look at it holistically, we can save millions. There was The Weeknd concert this summer. I'm not sure this particular case. I think either it was the one in Prague or in London. I think it's the one in Prague. So people went to the concert, they partied, they listened to their favorite artist, everything was great. 2 a.m. in the morning, they went home. They got hungry. They opened the Bowl Food app, and they placed the orders. The problem was that there was only one restaurant open in the entire city at 2 a.m., a pizza place. So I can only imagine somebody sitting in the pizzeria, listening to some Italian music, and that's how I imagine, on the background, relaxing, waiting to go home, and then suddenly he gets like 400 orders uploaded in 1 minute. So obviously he cannot make that many pizzas. Just like rejected them all, closed the shop, went home. That's it. We just got a spike of rejections. We're wondering what's happening, right? Small incident. We recently launched a new feature called scheduled orders. So you may already understand how it's working, but if you know what you want to eat tomorrow, you can order today. Simple. You can also use it for events. If you're preparing an event, you can pre-order food in advance. And that's what we did. We were like, hey, we launched this cool feature. Let's test it out. We're already partnering with some restaurants in Bucharest to test out this thing. And we're like, yeah, let's gather tomorrow to the office, make a huge party, let's order burgers. And people were like, how many burgers you want? And like, I could eat 2, 3 maybe. So we placed an order for 200 burgers, 200 French fries, 200 sauces, 200 drinks. We come the next day to the office, waiting for the order to arrive. And it was not coming. And we're like, what's going on? We went back at our laptops. We checked what's happening, and we sent one guy on a bike to get the burgers. So obviously, we fixed it quickly. Got our burgers a little bit cold, I have to admit. But in the end, we managed to eat the burgers and have the party. We fixed it afterwards, of course. Anybody wants to take a guess what people search in 2023 in Bucharest? What's Romania's favorite food? What do people look for? Shawarma? Anybody else? Mitch? McDonald's? Which one? Pasta? Kebab? Pizza? Burgers. Romania in 3 words. Now you've been waiting, 30 minutes to hear about the secret ingredient, and I might get killed after this, but there's no secret ingredient in bowl food. A cliche. It's just a whole bunch of ingredients that we put together and mix them up. And the main one that I want to talk about today is that we take iterative approaches. We try out new things. That's how we are able to launch completely new products in just a few months. Both food in 5 months, scooters in 3 months, car rentals in 3 months. It's already live in a few cities like Berlin, Tallinn, etc. That's how we are able to compete with giants like Uber. They have at least 50 times more resources than we do. So my message for you today is to go out there and try things. Don't wait 1 year to build a product and then get feedback from your customers. Just launch your versions. You've seen how we made iterative approaches to dispatching couriers, to menus. And do we make mistakes? Yes, you've seen. Sometimes your pizza may arrive cold. I think it still happens. Sometimes the customer support answer is not the one that you want to. I think it still happens, although it has been improving a lot lately, at least for me. Your groceries may be late sometimes. I think it still happens. But every day we try to make things better, and if you've been using the apps, you can see that every day there's a change. We try to make changes every day, every week, every month, every year to improve the product. So our mission for everybody is to make you all feel like Caesar and get your groceries delivered at your door. Thank you very much for having me.
Thank you, Dan. Thank you. Are there any questions for Dan?
You just forgot the slide with the discount.
Which slide?
The slide of the discount.
Oh, yeah. That's a really good point, yeah. Next year, I will make sure it's going to happen.
I have a curiosity.
Yeah.
Do you know why Uber Eats left Romania?
Yeah, I know that they were trying to get profitable. So then, you're gonna make that with kebab, right? They tried to get to become profitable, and they left the markets where they were not that profitable or on loss. And as far as I know, they were not profitable in Romania. So then they just closed it down.
So basically, you did a better job than
Yeah,
Uber.
yeah, exactly. With 50 times less resources. Uber is big in America, right? And that's where they make the most money.
Hi, thank you. Thank you for your interactive presentation. You mentioned the fact that you started using machine learning at one point, and I was wondering, since you took that decision and until you started benefiting from it, how long did it take?
Can you ask when did we take that decision and what's the benefit?
Since the time you took the decision to implement machine learning,
Yeah.
and how long did it take for you to start benefiting from?
Oh, okay.
Yeah.
Well, we started again with really small steps. I think it was 2020 or 2021 when we first started to look at it, so sort of like 1 year later after we launched. And we do the small things. First, we started to look at cooking time, but not the entire thing, but sort of have a small a small derivative sort of estimated cooking time that we would add or remove from the actual cooking time that the restaurants were giving us. And then we switch it to complete cooking time, and then we've added stuff like estimated expected times of arrivals for couriers. We added stuff like we know where they are on the map or where they will be when they will finish the order, so we predict also that, traffic, etc. So then things started to get more serious afterwards. But we saw improvement with every iteration, and that's what we look at. We make a change, then we look at KPIs and charts, see how things progress, right? And if it doesn't work out, then we basically make a change again.
Any other questions?
I have, I think, 5 more minutes until my scooter gets deactivated, so we can hang out a bit more. Then I don't know how I'm going to take it out of here.
Hi. You mentioned that you're implementing a
not a model, method, matrix or something like this.
Matrix dispatch.
Yes, to distribute couriers, to dispatch orders from restaurants. Of course, you have, let's say, every moment you have a static map where you have couriers and restaurants. And then when these deliver, they will be repositioned now in new position and then, of course, close to the dispatch point.
Yeah.
Do you have any optimization approach to make sure that at each of these steps you keep the minimum distances between next restaurant and couriers? I mean, have a consistent approach to this?
You're asking if we sort of try to predict the future and also try to optimize
Yes,
the costs in the future.
like you do for the cars when you distribute the orders so that you'll have a distribution of the
Yeah.
drivers based on the price model or something.
Yeah, to be honest with you, I don't know because all the machine learning just evolved a lot, and it's, as I said, way over my pay grade, and they've got many crazy things going on there. But I think we do. Yeah, I'm just like guessing that we do that as well. As I said, there are like some more presentations on YouTube that you can watch and get more insights about in the machine learning business side of business.
Thank you. I think we did have another question around here, or have I missing? I guess I was wrong.
Thank you very much
Thank
for
you so
having me.
much.